Hello, welcome everyone. Pajamas here, back from hibernation with another video for you. This time it's something a bit different. Instead of the usual gaming stuff we do, before you is a 3D printing slicer. And what I have for you today is a speedboat race entry, or a speed benchy as I like to call it. And what the speedboat race is, for those of you who don't know, is this boat right here. You want to try and print as fast as possible uh, within a given set of rules and parameters with a 3D printer. And this isn't a normal run either. There's other people with faster runs than me, notably Keen's Customs with a 9 minute run. But I also did something a little bit different as well. What I did is I gave myself an additional handicap for this particular run of sticking to Prusa's recommended settings for the most part. I'll explain that in detail later in the video, but yes, what I did is try to keep to Prusa's safety settings as best as possible. And not only did I do that, but I managed to get a 14-minute run out of it, which I did mention Keen's earlier, and I'll be comparing my print to his quite a bit later on. But I beat his 17-minute run by about 3 minutes, despite him pushing his printer way harder than I did in this run. And I'll show you how I did that as well. But with that being said, I'll show you the race, and then we'll go over analysis of the print itself, how it turned out, and also some of the slicer settings. And I know this is a burning question for you all: why even do these speedboat races in the first place? Because I know a lot of people in the community, or probably outside the community specifically, have that burning question. So I'll try and answer that the best as I can. With that, I'll show you the race and then we'll get into the analysis. Alright, before I show you the race, I just want to cover one last thing, and that is that both me and Keen's Customs are running our Prusa Minis pretty much stock, with the exception that he is running Clipper firmware. I don't think we really count that as modding the printer too much. The hardware is pretty much the same. On my end, though, I did exchange the nozzle for a hardened steel 0.5mm nozzle, which is the max nozzle size you would be able to use for the speedboat race, along with the same extrusion width. Also, I did put a silicone sock. I don't think people consider that much of a mod, but yeah. Those are the only mods on the printer, and I think for this case, you could get a 0.4mm nozzle and get very similar results. With that, let's get to races. And that. Wow. That was just shy of a 14-minute speed benchy. Let's see what our let's see what our time got us. It's rough. So what do you expect the benchy to be? I would almost say it looks like a benchy. Alright. With that, I'll see you in the analysis part. Alright, so this is the analysis part of the video, and right off the bat, what we could see here is it does look rough. This isn't a prettiest benchy, but it doesn't have to be. All it needs to do is look like a benchy and not fall apart on itself. So to that end, we succeeded, along with printing this as fast as we can. It did come out pretty fast, even despite the settings, which I'll mention later on. But one of the things I want to point to as well is you'll notice that there's this big overhang, this big rough area near the overhang at the front of the ship. That could be cooling. I would imagine at least that's attributed at least partially to the the lack of cooling, because when you're printing out so fast, the material doesn't have enough time to cool down. And you can kind of see that with the string as well. We are running this pretty hot in order to get the speeds that we want, but I think this could be another issue as well. For my particular prints, we do have the jerk or corner speed set really quite high. And what that'll do is when the printer's moving around, in order to get accurate prints, it needs to be able to slow down as it's going around a corner so it doesn't just slop around all over the place. When you set that really high, what that does is, the printer simply won't be as accurate, because the nozzle, or the heat hot end, as you can see here, it'll just be sliding around a lot more because we're not slowing it down as much in order to get those accurate corners. So I think that's what that is. That being said, the bow closer up here is relatively nice. I would say that was almost perfect. And then of course you have the top here where it just gets messier. Apart from that, I did mention string. The first layer, you could kind of tell in the race entry, also from looking here, it was rough and some of the material didn't quite adhere as well as you'd like it to, especially if you're not doing a race and you're just doing a regular print. It was rough. A lot of the material is coming off because, again, we want to print as fast as possible. That being said, it did ultimately adhere to the print bed. That's good. The bridging, surprisingly, I know it doesn't look good up top, but for the most part, I've done practice runs where the bridges just didn't exist. They pull themselves apart whenever you try to bridge. It's not terrible. I know, especially this first layer here where the where the little ceiling is, that actually came out relatively nice. I know a lot of it's looking rough, but we're trying to go as fast as possible. You gotta take every, quality is more of a bonus than anything else. And other than that, as you'll notice here, this is pretty much par for the course whenever you're printing super fast benchies. Chimney is going to be a giant blob, basically. Not much we could do about that without slowing down the printer. Like I mentioned earlier, you're just dumping as much material as possible, and when you're dumping hot filament onto the print bed, it's just not going to have time to cool down, especially when you're doing layer after layer, probably like one layer a second. If you get into the faster printers, probably multiple layers a second, all going right here. So, other than that, it didn't turn out too bad. Obviously, if you're going for quality, you're going to slow everything down, which I will, again, I will go over how you can get faster and also quite nice looking prints still, based on the results we have here. With that, let's head back to the slicer. All right, onto the slicer portion of things. One of the things you might notice right away is that I have my print oriented diagonally as opposed to its normal orientation, or you know, just pointing in a straight direction. And the reason I do that is because when you have a print oriented diagonally like this, at least on a bed slinger or a Cartesian i3 style printer, is when you orient it like this, the motors can sort of work together. They let you reach, let you have a better max acceleration. They let you hit your top speed faster, and the reason being is when you're going along these diagonals, both motors can work together to let you reach that top speed faster. Even around these corners, one of the motors is going to have to slow down, but the other one can kind of keep chugging. It doesn't have to slow down that much in order to go around that corner pretty fast. It just saves time. Like, I'll show you right now. Right now we're at 14 minutes. If I were to orient this, let's see, -45, so it's pointing straight up. On your normal prints, okay, see here, 15 minutes. So we saved a minute roughly. It doesn't give us exact seconds, so I'm guessing it's about a minute. On a normal print, it's also going to save you 1 minute. It's very minor. It's really not going to affect your print speed too much, but in our case, 1 minute is a lot of time to put on the table. So we orient the printer like that, or the print like that, so that we could get just that little extra speed, that little extra acceleration. As far as the printer settings, one of the things you'll notice is, so pretty much everything here is stock. This is what Prusa wants you to use, except for the jerk or corner speed. Those are set way up high, and I believe, I can't confirm, I thought I saw somewhere in the description, the corner speed settings are a lot lower, and like I mentioned, he's using clipper, so he could if that's the case, then he could very easily turn these up. And because he's using clipper, the reason you want to use clipper for a speedboat race is because it has a feature called input shaping, which when you're going around those corners at a really high speed, instead of the nozzle slopping around, it'll be able to compensate for that high speed movement, and it'll be able to print fast and more accurately, which in a speed like this could be the difference between your print, getting a really fast print and either having a failed print or having to slow down all around those corners in order to get a successful print. I know the quality of the benchies are rough, but a failed print will not qualify. You won't be in the race. So your print does have to finish, and it has to look roughly like a benchy. When you have input shaping, that just makes it that little bit easier. It also makes your prints look better in general. So yeah, it's very good thing to have. Of course, I'm running my Marlin firmware, so I just have to deal with that nozzle slopping around. As for accelerations, speeds are exactly the same. Nothing to talk about there other than they're really rather safe. I've seen people push their printers far faster than this. Even as far as Prusa Minis are concerned, you can push this way fast. I'm not sure. I think they use the same motors as the i3s, but regardless, there's a lot more pep in them than Prusa gives credit for, or they want to avoid burning out your printers fast, which is a good thing. But the one thing I did turn up is maximum acceleration when extruding or retracting, which is about half speed. The reason I did that is because the limit for being able what Prusa thinks the motors will be able to handle reliably is 2500, so I decided to push it just that much to about 2500. It's not terribly fast. You can push it far faster than that and still get relatively decent looking prints. when you're printing normally, I would turn this down simply so that your part is stronger and it looks better. But for our case, for racing, we want that high. Now, as far as the extruder, I did tweak that quite a bit. I essentially made it where, lift Z, it'll never lift the Z unless it's switching to another layer, or for the mesh bed leveling. Otherwise, that Z should not move. Minimum travel after retraction. This is it's a little bit misleading or not exactly clear. Minimum travel after retraction is how far the nozzle has to travel in order to retract. And I set that to the width of the bed so that basically we'll never have to retract. It would have to travel all the way across to retract, and it's not going to do that for our case. Retraction speed, de-retraction speed, I did turn those up. Again, it shouldn't matter though, because we don't really want to retract. I should be putting out material all the time. That would probably explain why I had that stringing, but again, we want to go as fast as possible. For regular prints, you probably don't want to do this. Other thing I did is, this is where I kind of handicapped myself. We set the max volumetric speed to the recommended 15 millimeter cube per second, which I thought was rather low, but when I was slicing, doing some experimentation, it was only about a minute loss. So it really doesn't affect the print speed too much. That being said, at some point we're going to turn it off, go full ham into this. But yeah, for our purposes, Prusa says that's safe, so we're going to leave that for our print. As far as speed, extrusion width, layer height, this is the max that we're allowed to have, and I think even if you're using a 0.4 your typical 0.4 millimeter nozzle, 0.25 layer height by 0.5 extrusion width is relatively low. I think more so in extrusion width. As I'll explain later, you could crank that way up and your prints will be faster for it. But rules are rules. We must follow them. The important part is infill. I use the minimum 10%, but I use lightning infill, which is a type of adaptive infill. Most people will probably use line, and let's see, you probably won't lose that much speed. Yeah, see, we barely lost any. I think it went from 37 to 57. We lost 20 seconds. In case I do have to redo this because for some reason support material or support infill isn't allowed, but I doubt that'll be an issue. If it is, I'll do a reprint, I promise. That being said, lightning infill. As I'll show you right now, it is not a lot of infill, and you really don't need a lot of infill even on your normal prints, like you can see here. It just goes over where it'll support that square there, and then everything else. So you really, this one you can apply to your regular prints. You really don't need that much infill. I'll go over why very shortly. But yeah, so main thing I changed, infill. Everything else, layers, you can see here. And by the way, I will link the G code and the 3MF files so you can take a look at those. Tell me, tell me how exactly that I'm cheating, and then I'll be able to fix those for next race. But yeah, let's see, 3 top bottom layers, the maximum allowed layer height, no support material, we don't need it, no skirt or brim because we definitely don't need it. Speed, I know that's set to 225. Printer settings, the machine limits take precedent. You could set that to 1000 and it'll default to this because that is the lower value, that is our limit. Well, exteriors, we don't have that. and of course the extrusion width, which we'll use 0.5 because that's the max allowed all the time for the race at least. All right, so now for that burning. Now that we have the analysis of our print out of the way, why would you even want to do the speedboat race at all? I know a lot of people will say that speedboat race is kind of pointless. It's all for show. All you're doing is making bad prints and ruining your printer. And I would say not exactly. I do kind of get their point that all you see is the printer shaking itself to death and the print looking like hot garbage. But that hot garbage that comes out of printer will tell us a lot about not only our print settings, what we can improve to get the best time possible, or for that matter, a really high quality print. It also tells us how our printers can improve. And if you've watched other races before, you might know that one of the big issues with printing is actually the hot end. The extruder, the part of the printer that turns 1.75 millimeter filament into this. That can be very much limited. The other big limiting factor is mainly going to be cooling in order to get prints out as fast as possible. So cooling and the hot end, those can definitely be improved on the hardware side. As far as the slicer side, what you can see here is some stuff obviously you have to keep tuned down in order to get as good of a quality as possible. For example, mainly external parameters, you would want to keep. Well, okay, I need to go to speed. You want to keep this rather low, and I'll show you one of my presets right now. Just go ahead and discard that. You can afford to turn up parameters a little bit. You can definitely afford to turn up infill and top solid infill. For the reason that, like I said, use lightning infill. There's barely any infill that's coming out. And the reason why is infill is really overrated. A lot of people seem to think it's important for strength, but it has one primary purpose, and that is to support your top and bottom layers. And considering the fact that let me turn off supports here. Considering the fact that the bare minimum that you need, you probably saw earlier already, but yeah, that's the bare minimum if you want your print. And there is nothing on like the first couple of layers, and it only gets bigger later. Don't get me wrong, infill can improve your speed, your strength. It can make your parts stronger, but there's other ways to do that, which I'll talk about momentarily. The bare minimum to get the print to come out is probably not even that. You could probably even trim that down further, but that's what I used to get when I want my stuff to look nice. That being said, you can turn up a lot of speeds at least a little bit. Again, Prusa or any other company that gives you presets like this, they're going to give you rather slow, slow and safe profiles, so you can get good looking parts that they probably don't want them to take too long, but they will err on the side of safety and quality more than anything else. And a lot of the time you don't need that to get good looking parts. That being said, one of the other things we could definitely crank way up, even when you want to get the best looking models possible, is our extrusion width. As you can see here, I have a 0.5 millimeter nozzle on a 0.4 millimeter nozzle. This will be about 0.5, but actually let me just switch over to a 0.4 millimeter preset. That way the numbers are a little bit more familiar. I have everything set to 0.5. If we switch that back, they're way lower. They're basically right along what the size of the nozzle diameter is. And I've watched a couple of videos. I think CNC Kitchen did a video on this. You can crank these even further than that. If we go to let's see, one of my presets here, discard. You could crank it up all the way to 150% of the nozzle diameter, the extrusion width, and as far as I know, your prints will look. You won't be able to notice any change in quality. At the same time, your prints will just come out faster. They'll be stronger for it. Um, you're basically getting a free upgrade on your prints. Maybe you'll use a little bit more material, but overall you're getting better prints for free. You can afford to crank that up. I know the rules say 0.5. When you're making normal prints, you can afford to tune that up. And as a bonus, that will save you from having to wear out your motion system when you do your prints like this. Now, one of the other things is, again, infill. You could afford to turn that way down. You really do not need that much infill. I recommend when you're doing a normal print, always use some sort of adaptive infill. You really don't need that much. Adaptive cubic is pretty good. It puts material right where you need it, and then it fades out as you get into your middle. That doesn't really show it that well, so I'll go ahead and enlarge this. All right, finally. All right, so what we got here is, you'll notice that as you get close to the bottom, the top, or the sides, the infill will start to thicken up. But near the middle, there's a lot of big holes. And the reason is, when you're making a print for strength, to make it as strong as possible, you really want that strength around the edges. That's where the most strain is going to be on your print. The middle, the opposite, that's probably where you're least likely to need material, simply because this isn't going to be moving a lot, but the edges, they're going to be stretching it and flexing a lot. So when you use adaptive infill, that automatically does that for you. It's optimized to get the most, the most efficient use of your material. Put the strength where you need it most. And for that reason, that's why I also recommend turning up your layers, you could turn up your top and bottom layers too, but the main thing you want to do is set your perimeters high when you need to have tough parts, because again, that's where your parts are going to be stressed the most. I think for my full tech thing, is going to be 4 perimeters, and 4 wide perimeters at that. I have it set to 0.6 almost across the board, except for external perimeters. Just to get that extra quality in. But so you're getting 4 perimeters and going to be really thick. I really recommend orienting your print parallel to where you need the strength, where the most stress is going to be, just so that those perimeters are working together. Because again, all the stress is going to be, around those edges, the edges where it's going to be most strained. We don't really need to finish. Okay, there it goes anyway. But yeah, as far as prints that look good, I would still recommend. I'd recommend making your perimeters a little bit fatter than usual. You can use an extra perimeter just to make sure that you get proper thickness on everything. If you try to use infill, it's going to be a lot slower, and it's probably not going to look as good. I know I turned jerk up a lot. You probably don't want to turn it up nearly as big as I had it, but you can turn up the corner speeds a little bit, and you'll probably get similar looking prints, if not slightly better looking, if you turn it up a little bit, especially if you have clipper. Because those are set really low, and what ends up happening is essentially when you have speeds like this, your nozzle won't stop, but it's pretty much going to go almost to a standstill, which could have other effects if you turn that too low. So you want to have a little bit of velocity when you're printing. I'd probably turn that up maybe to 10, and then adjust that until your print head starts slopping around, and then dial it back. That's the cool thing about the speedboat race is you could set everything stupid high and then dial back the more important parts, or you could dial things back. Uh, you can leave the unnecessary stuff a little bit faster and then dial back everything else near where it was. Um, One of the last things I recommend is just tweaking. Don't be afraid to mess with profiles. Obviously, don't set everything to like some infinitely large number. Be reasonable, but for the most part, you could tune things up a little bit. Maybe tune one setting 5 to 10%. Probably less than that once you get to higher levels. But you could tune everything one thing at a time. See what it does. I just recommend tweaking your settings, seeing what you could get away with, even what makes your prints look better. Because ultimately, not everyone has a Prusa Mini. Not everyone has an Ender for that matter. There's all sorts of different printers, and they all have different strengths and weaknesses. So it's good to be able to tweak, see what you can speed up, see what things are going to ruin your prints if you turn them up too much. 3D printing itself is still kind of, I know people give 2D printers a bad rep, but they're at the point that they're pretty much reliable. You push a button and your ink on a paper comes out really fast, comes out pretty nice for the most part. These nail off tweaking. Even for the same model of printer, your printer might have some quirks to it that you should reflect in the profile settings. That being said, I think that's enough rambling for me today. Thank you for those of you who have tuned in. And with that, I hope you enjoyed. I will see you probably in about 6 months to a year once I go back to hibernation here. But in the meantime, stay safe. Hope you guys enjoy yourselves and chill out. Oh yeah, one last thing. Just to let you know, 8-minute benchy that could be coming up in your future. I can't wait to put that out and then immediately get beaten up by Keens with a 7-minute printer or something like crazy like that. But yeah, with that, peace out. Oh, timer's dead. Oh, wow, that's not good. Oh, crap. Yeah, I'd better put out a misery. Rip. It's not good. It was, no, that was terrible. Everything that could have gone wrong did. Probably still gonna put this on YouTube though.